Okay, so this is the demo on the lab for the flip-flops. So what we need is the development board, because we need the 5 volt and also the ground supply from this development board to power the flip-flops. So the 5 volt will connect to the VCC pin and the ground will connect to the ground pin of the flip-flop IC. So we connect it to the power supply pin. Then this is the switch to on and off the board. So after we on, the LED will be lights on. So for connections, we off it first. So after that, we need to have two male to female cable. So this is a female and this is a male. This is a female, this is a male. So female to male cables. So you connect it to the 5 volt and also ground of the development board. Then we can connect 5 volt to the top and ground to the bottom. Okay, some students would like to connect them next to each others, but for safety purpose, it's better to put them far away from each other. So that's why I put one line at the top, one line at the bottom. We don't care about the notation here. We just need to know where we connect the power. So this pin will be the 5 volt, this pin will be the ground. So this whole line will be 5 volt and this whole line will be ground. Okay, and remember one thing, these two lines is not connected to each other. So if let's say if you connect something in here, there will be no power supply. Okay, if you want to use it, you need to get another male to male cables to connect between the two lines. Okay, same go to the other line, horizontal line, at the two at the bottom and two at the top. They are not connected, there's a break in the middle. So this is something you need to take note. So the first thing we need to do is I will get the IC for the D flip-flops. So I will start with the D flip-flops. In this IC, this is a 74LS175. So it is for the D flip-flops. And in the Tinkercad simulations, we are using 74LS for 74. 74 HC74 in the Tinkercad, which is the same as the one in the lab box, which is a 74LS175. Okay, so they are used for D flip-flops inside. So I think you all know how to know the first pin and the last pin. So refer to the U shape. So there's a U shape at the top of your IC here. So means this part is the top part. So the first pin will be at here and the last pin will be at here. 1, 2, 3, 4, 5, 6. And then turn one now until the last pin here, right? Then we need the data sheet of the IC so that we can know about the pin layout. So if you look at here, this is the pin layout. So this is the first pin and this is a U shape. So this is top. So this is the first pin. First pin will be the clear signals for this IC. Okay, then we need to connect the VCC and also the ground pin. So VCC will connect to the 5 volt here. The ground pin, which is the ground pin, will connect to the ground pin. So let's do the connections. I connect the VCC to VCC pin, okay, the 5 volt. Then I connect the ground to the ground here. Okay, so now the VCC connected, the ground also connected. Okay, the next one is we need to make sure there is a connection to this clear pin. As we learned in the lectures, this is a synchronous clear pin. So it means we can clear the output of these flip-flops at any time we want if we give a low signal to this clear pin. So in order for us to use this IC, we don't want to clear it, we should connect it to the VCC, which is a high signal. So it won't clear the output of this IC, right? Then the next thing is to connect the output, which is the Q. So we just look for one output should be enough because Q and Q bar is a complement to each other. So Q is high, Q bar is low, Q is low, Q bar is high. So I just need to connect one of the output to check whether this flip-flop is working fine. So I using there's in here you can see there's a 4 flip-flops. 1D is the input, 1Q and 1Q bar is the output. Then there's another 2D, 2Q, 2Q bar. So there's total 1, 2, 3, and 4 flip-flops in this IC. So now I'm using the first, let's say I'm using the first flip-flops So I will connect the 1Q to my LED. Okay, so this is how you can do the connections. So this is my 1Q. I connect it to a register. Then the side of the register will connect to one of the pin here. Then I will connect the LED. So the LED, you need to know the priority. The positive side should go to the register here. The negative side will go to the ground. So the longer leg is the positive side, the shorter leg is the negative side, right? So we just connect it to the board. So now I complete the output signal circuit so that I can monitor whether the output is 1 or 0. So if the output is 1, this LED should be light on. If output is 0, this LED should be off. So after this, the next thing will be the clock signal. This is a edge trigger flip-flops, so we need to give a clock so that it only will respond to our input signals. So there's a few methods to generate a clock pulse. One of the way is to using the clock pulse from this Liverum board. If you look into this board, there's LED here. So means there's a pulse supplied to this LED, and it's basically supplied from this pin, P2.0 pin. So you may using this pin as a clock to your flip-flops. This P20 pin. If you look at it, this is the P20 pin, the last pin here. Okay. So I was using one of the female pin. Okay, I can use another female to male cables to connect to my last pin here, which is the P20. Right. Connect to your P20. Then the other side, the male parts, you connect it to the clock pin of your flip-flops, which is the one in the pin layout here, the pin number 9. Right, so now I have supplied the clock to this IC. I supply the power, the ground to this IC already. The last thing is to give the D input. So let's say now you see the LED is on, right? So let's say I want to give a logic 0 to my D. So my D will be at pin number 4, right? So this is my 1D. So I connect it to the 4th pin. Then let's say I connect it to ground. It should go off the LED, right? So I connect the ground is off. So the next thing I will try to connect to 1. So I connect to 1, it will be light on. Okay, due to the circuit design, whenever I just pull out, it will straight away go to high, but actually it's function because the clock is keep on giving the signal, right? The LED is keep on blinking, so there's a clock pulse giving on. So whenever the pin, it will straight away go to high if nothing connected to my D, right? So if I want to check it again, is it working well? I can connect it to the ground signal. So the LED should go off, right? So this is how we test the D flip-flops. So if let's say you want to control the clock by yourself, we can using a push button. Okay, you can using a push button to generate the clock ourselves. So let's say I disconnect this pin. So I don't want to using the board to supply the clock pulse. So I can using a push button. So this is a push button. So there should be a 4 legs. So this push button is working in this way. So these 2 legs is connected to each other, and this 2 legs is connected to each other. So this side will connect to the other side. Okay, so these 2 pin is connected to each others, and then the other side, the 2 pin also connected to each others. So for me to connect this side to this side, I need to press the button, so only they will connect to each others. So this is how we should put the button onto the breadboard. Okay, put it at the center also. Okay, so this two pin at the top is connected to each other. The 2 pin at the bottom is connected to each other. So in order for me to connect them, I need to using press the button so that they only were connected to each other. So when we connect it here, it should be connected this side, and this side is connected. So in order for me to press the button, then only this side will connect to this side. So in order for to generate the clock pulse, this is circuit we should do. We have a VCC, then this is a resistor. So the resistor connect to the VCC, then the other side connect to the push button. Then the other side of push button should connect to the ground. Then this point between the resistor and the push button should go to the clock signals. Okay, so if you look at it, if I didn't, then this is open circuit, so there's nothing connected to ground. I only have one way, which is the VCC. So I will send a high signals to my clock. So when I push a button, this switch will be closed. Then the clock will go to the ground because this side has no resistance. They will try to go to the easy path. So that's why they will get a low whenever I press a button. So if I release a button, it will go to high back again. So this is how we generate the clock pulse, by pressing the button. If I press, it will go from high to low. If I release the button, it will go from low to high. So this is the connection we should have. So now I will connect one of the VCC pin. Okay, I connect the VCC. I'm using one of the resistor. I connect the VCC to one of the leg. Okay, remember there should be a diagonal because these two pins are connected to each others, and these two pins are connected to each others. They were only connected when I press the button. These two will connect to these two. So that's why now I connect to this pin. Then when I press button, it should be either this one or this one will connected to this. So I will put the ground to this side. Right. It's always in diagonal. The top side here, the bottom side should be here, right? And the last thing I need to connect is to connect the center between the intersection point between the resistor and the push button, as the one in here, this point, in the PDF files. So to the clock. So by doing this, I basically completed the circuit. So if I let's say I release, there will be no on LED anymore because there's no clock pulse, right? Because I didn't press the button. So now I can change the output, the input to high now. So now the input is at high. So let's say I press the button, you should see the LED go up high, right? I press and release, then the LED will be on, right? Because this is a rising edge trigger. So when I press, it's going down to ground. I need to release, then only going up back. So let's say I chain it to the ground. So this is a flip-flop. So it only reacts whenever there is a rising edge. So without pressing the button, I won't give any clock pulse to the clock. So now let's say I press it and release, this LED off again. So this is how the D flip-flop should function. Okay, so the next flip-flops will be the JK flip-flop. So in here will be the 74LS107A. In the Tinkercad, it is equivalent to 74HC73. So it is also JK flip-flops. So in the hardware lab box, we are using the 74LS107A. Okay, this is the JK flip-flops. So the left hand side is the pin layout for these flip-flops. So the same, they have the VCC, they have the ground. So we need to connect these two pins. Then in here, there's only two JK flip-flops. So there's 1J and 1K. So these two will be the input. I have an input 1K and input 1J here, right? So they have the two output, Q and Q bar, the same. We just need to using one of the output, which is 1Q. Then there's another one, which is the 2J and 2K, and also 2Q and 2Q bar. So there's only two JK flip-flops in this IC. Then there's also the clear, asynchronous clear, and also the clock for each of the flip-flops here. So we need to do the same. I connect the VCC and ground. So I just pull out the one in previous pin, VCC and ground, and same thing. I need to link the two branch here. Okay, VCC and ground, and I need another VCC. So this will go to VCC. Okay, so I done the connection for VCC and ground. So the next thing is to make sure the clock is high. So the clock is in the pin 13, the pin next to VCC. So I just connect it to high, so I won't clear the output, right? Then the next thing is to connect the LED, right? So the LED should go to 1Q, which is the pin number 3. 1, 2, 3. So this is my 1Q. Then I connect the LED. Okay, done. So I need a clock. So the clock can be used, the one from the board, which is a P20, or the push button. So since I have built the push button, I can use it as a clock. It's the third pin, so it's next to the clear pin. Okay, the third pin at this side, so it's next to the clear pin. So I complete the clock, I completed the clear, I completed the output. So now is to give the JK signals. Okay, so let's say I want it to keep on toggle. I should give 1 1 to my J and K. So the J is the first pin, K is the fourth pin. So I connect J to 1. I connect the fourth pin, the K, to 1 also. So now the LED is light on, right? So let's say if I press the button, it should off, right? It should keep on toggle, right? It should keep on toggle your LED. It's okay. Sometimes it may even have a two response, because this is a push button. It may have certain noise whenever we press the push button. It's a hardware kind of thing. So there should be have some noise when we press. Even we press one time, maybe there's already a few times clock giving out. Okay, right? So you can see if I release it faster, should be a clear clock signal. So you can see it's keep on toggle itself, right? Okay, so this is how the JK flip-flop functions. So you can try with the, let's say I change it to J equals to 1, K. Okay, so now should be K equals to 1, J equals to 0, so that we can see the LED is off when I press the button. Right, so now even though I keep on pressing, it's still 0, right? Because your K is 1, your J is 0 here, right? Then we try to swap it, change to J is 1, K is 0. It should be on the LED if I press the button, right? So it's on. Okay, so this is the connections for your JK flip-flops. So now we'll go to the last IC, which is the D-latch. So it is a 74LS75 in the lab box. So the one in the Tinkercad should be 74HC75. It's the same number, it just changed from LS to HC. So they are the D-latch. So this is a pin layout for the D-latch. The only difference is the VCC is at pin number 5 and ground is pin number 12. So now let's connect it. So this is the ground, pin number 12. So it's a 1, 2, 3, 4, 5. This pin. Okay. Then I have the VCC. Okay. VCC is at the pin number 5 also. 1, 2, 3, 4, 5 this side. So I connect it to VCC. Right, so it is a latch, so it's only have enable signals. So this is the, so in here if you look at it, there's a 4D latch. So I have 1D, then 1 Q bar and 1 Q, 2D, 2Q bar and 2Q. I have a 3D, 3Q bar and 3Q, 4D, 4Q and 4Q bar here. So this is the pin to enable. So I have an enable pin for 1C and 2C together. They are the same pin. Then I have 3C and 4C in the same pin here. So let's say I'm using the first one. So I just connect the LED to the first one. I connect it to 1Q. Should be 1Q. So I connect it to the first pin here, right? 1Q is the first pin here. I connect it to the LED. So then I need to have the enable signals to my 1C, right? So I should enable it. My 1C is next to the ground. So I put it to high, so only if it works. So now it's LED is on already. So let's say on the off it, I need to have 1D. 1D is the second pin here, the input. If I connect to ground, it should go to ground, right? This is the latch signal. If I connect to ground, it should be ground. If I connect to 1, it should be ground 1. So in default, I think the circuit will be on whenever there's no connections to your 1D. So that's why I can test it only using this method. Another way, if you want to have a better visions, you can also using the push button to your 1D so that you can control your input signals. If nothing giving, it should be ground or should be 1 by using the push button. So I connect my push button to here. Then I connect my 1D to my push button signal. So if I didn't press, it should be 1. If I press the button, it should be ground, right? So if I release, it should go back up to high, right? So this, you can see it clearly. So it's basically a D latch. So if I press the button, it is connecting. The input D is connecting to the ground here. If I release, the input is connecting to the VCC here. Right. So this is the 3 lab experiments for your D flip-flop, D latch, and also JK flip-flops. So I think that's all for this lab demo.